Okay, hey everybody. We're going to resume with our talk, so please finish up and take your seats. And back in after the break, CICD is hard because you have to deal with very, very messy topics like security and like compliance. So very happy to have these good folks from Northwestern Mutual here to talk to us about real world and how we deal with compliance.
Test.
Okay. Hey guys, thanks for coming. My name is Ravi Devineni. Michael Pereia is with me as well. We're from Northwestern Mutual. We work on a team called DevOps Engineering Team. Our job is to basically create tools for CICD to enable development teams to ship applications faster and in a more secure way. I'd like to thank Continuous Delivery Foundation for giving us this opportunity to present our work, especially in the presence of our hero, Kosuke is here. Thanks for joining. So a little bit about our, is it on? This one is working?
Okay.
Oh, there we go. A little bit about our company. Northwestern Mutual is a financial services company headquartered in Milwaukee, Wisconsin. We have locations in New York City, that's where we're both from. We have remote offices in Minneapolis and Phoenix as well. Fortune 104, America's Best Employers, 367, Best Employers for Women, Best Employers for Diversity, Veteran-friendly, LGBT-friendly. So you can see the theme there, very diverse workplace. You know, in addition to all of that, we're working on some amazing technologies in cloud and DevOps, some very challenging problems to solve. We are trying to bring digital transformation to a 160-year-old company. Great work-life balance and all that, very flexible and empathetic senior leadership. It's a great place to work. So the agenda for today is we're going to talk about CI/CD pipelines and what security means and what compliance means. What does it mean to actually secure a pipeline? Some concepts around security of the pipeline and security in the pipeline. And I'd like to do a Q&A session because so far the talks haven't had much Q&A. Would like to make it a little interactive. Some of the tools we have developed also as a part of enforcing security controls in the pipeline. CI/CD pipelines. So I thought Tracy Reagan did a good job describing what a CI/CD pipeline is in her earlier talk, but I'm going to do my own spin on it. So remember in the old days, many years ago, before Jenkins came along, we used to do waterfall development, coding, lifecycle building, deploying into staging environment, testing environment, and all of that, and then on a weekend or maybe on a Tuesday, deploy it to production environment, right? All of that, replacing all of that with manual, is a lot of manual effort there. So replacing all of that with automation, that's basically what CI/CD is about, reducing the human element there. So a lot of benefits of doing CI/CD, right? So you're doing code changes on a smaller level. So you're releasing smaller code changes to all the environments. As a result, there's faster feedback because you're releasing changes on a smaller increments. Also reduce manual errors because you have pipelines, you have functional testing and all of that inbuilt in the pipeline, and your failure is faster and quicker. And also you're releasing features to production to the market faster. As a result, you have higher customer satisfaction as well. So this is an interesting slide. So this is the number of CVEs that are discovered every year, right? So if you see, the data is as of this morning. There's an uptick in the number of vulnerabilities discovered in the last 3 years. So 12,174 as of today. So that's an average of 40 vulnerabilities being discovered every day. So this is 40 new vulnerabilities discovered every single day. There's more vulnerabilities that are, these are discovered and disclosed. There's a lot more vulnerabilities that are there. They haven't been given an ID or anything like that. So all of these have IDs associated with them. What this really means is that there is more ways in which an application can be exploited. As a result, and Christy mentioned earlier, security is a first-class citizen. All the companies here are focusing on application designed with security in mind. Security is going to be a first-class citizen going forward. And this is another example. This is a tool called Shigit. It's basically it's a very useful tool to find secrets and sensitive files across GitHub in real time. There's a lot of secrets being committed. So you can see there's high entropy strings, You can see some Google Cloud API keys, and those are real keys. PHP configuration files, private keys, usernames, passwords.
It was from in 20 minutes run, right?
This ran for 30 minutes, and if you leave it on for a lot longer, this is real GitHub.com code. So if you run it for many hours, you'll see a lot more. And so DB connection strings and all of that. So this is basically keys to the kingdom. So if the developers are being, in a way, reckless to create all this code and putting secrets in the code, it's easy. If I were to be a hacker, why would I even go break a network? I would go to GitHub and find a key and just use it and open the network. So it's that easy to do this. So the goal of CI/CD security is to basically find the security issues as early as possible, because the later you find them, the more expensive it is to fix them. There's this study that IBM did at one point, and they do it every year, is that the average cost of a security breach is $3.92 million. And no company is exempt. Every company is taking security as the highest priority. Financial services, we come from there more so. Equifax was a very famous breach. We'll talk about that in a second. Yahoo, Verizon, Target, all these companies got breached. And some of the security breaches, Equifax, for example, right? Very well publicized one, 150 million people's personal data got exposed. That's pretty much every single adult in the United States. That's all of us. And Equifax had to pay $1.4 billion to get out of that. So I hope you guys claimed your $125 check. The reason that happened is Apache struts. They were using a version of Apache struts, 2.2.2 or something below that. And there was a vulnerability that was discovered in 2017. Apache struts is basically an open source software. And they never patched it. And as a result, it got exploited. So Equifax is in trouble now. Verizon is another well-publicized case. They had a third-party vendor where they put all the data, customer data, in a public S3 bucket, and that got exposed, and Verizon had to pay a lot of money to get out of that. Not just these, right? So companies like Capital One, Uber, Facebook, all of these are getting into trouble because they are not doing security properly. So this is a very big problem that we need to solve. Some of the concepts around security of the pipeline and security in the pipeline. So this is the diagram that we put together. So this is essentially what a pipeline looks like, right? There are several stages in the pipeline. You have idea and planning. That's where you get your idea. You have a tool like Jira, LeanKit, or maybe even spreadsheets, right? And you put your ideas there, stories and all of that, and then you start coding. And for coding, you use GitHub, GitLab, hopefully another, not CVS, hopefully another Git-based tool. And then there's the build stage where you have tools like Jenkins, GitLab CI, Docker, Packer for building AMIs and stuff. And then there's the scan stage. Scan stage, you need to have a lot of security scanning there. SonarQube is one of those tools that we use on our team to basically sort of a linting-like software, but it definitely has some security checks there. Checkmarks is a static scanning tool. OWASP Zap has a sort of a baseline scan for dynamic scanning. Claire and Twistlock are container scanning software, so you're basically, if you're building containers, you're including Claire and Twistlock to scan your containers and find vulnerabilities in your containers on a frequent basis. X-ray, software composition analysis and dependency scanning. JFrog guys were here earlier. JFrog X-ray is a good software. Artifact stores, and once you have the scanning and testing done, you build your artifact and you store it in an artifact store. For that, you have tools like Nexus. Sinopia is an open source software. Docker registry. JFrog's Artifactory, it's another good one. And for deployment, you can use tools like Terraform for infrastructure, Ansible, Kubernetes for container orchestration, Docker Swarm. And then once the application is deployed to production, there's the monitoring and RAST and RAFT tools. So in short, your application is going through so much, right? So there's a lot of tools within the pipeline, and your application is going through several scans. So the part where you're enforcing security checks of the application, making sure your application is secure in itself by making sure you have all these scans in place. That's security in the pipeline. You're making sure your application is secure. But not only that, right? All of these tools that you see here, they have access to your application code, your secrets, your environment variables, business logic, all of that. So if any of these tools get compromised, then you're in trouble too. They just need one of these tools to get compromised to get access to the data and stuff. So security of the pipeline really means you're securing all the tools used in the CI/CD pipeline, all the tools that we saw earlier. Some of the principles we use for doing that is called principle of least privilege, essentially making sure that only your tool only has the necessary amount of access that it needs to do the job it needs, amount of permissions and resources for that matter. Also, you need things like minimizing the attack surface area and hence the blast radius, right? You want to ensure all your communications are encrypted, underlying operating system is secure and all that. Some of the examples that we have here are for GitLab, for example, GitHub. We want to ensure that repository settings are compliant. Merge requests, for example, you don't want to approve merge requests you don't want to merge a merge request without somebody approving it. You want to make sure your default branch is protected so it doesn't accidentally get deleted or people don't commit directly to the master branch. Authentication and authorization. You want SSO enabled in theory. If you want your company, only people in your company to access the code, SSO needs to be enabled so there's no public access to all the projects. Ensuring all the projects have the right amount of authorization. Only the right people who have access to who needs access to the project have access to it. Ensuring all the buckets and any cloud resources are private and encrypted, ensuring encryption at rest and in transit. So how do we ensure all of these pipeline tools are secure, right? The answer is really to automate it. You write a software for it. So we have done that on our team, and we'll call that software as CICD Auditor. It's nothing but a rules engine, just a simple rules engine. What it does is it checks for security configuration of all of the tools that we saw here, and ensuring that we're following each of these principles here, we laid out here for each of those tools. And then we come up with a whole bunch of rules, and we check for those rules on a daily basis and send alerts when some of these rules are failing. And so obviously some rules do fail. There is valid reasons when some tools fail. So that means you just need to do extra work to harden the security of those tools. So this is an example dashboard where we show the results. This is false data, by the way. Public projects, what that really means is you don't have any projects that are public facing. If you're using github.com, for example, for your company, you don't want everybody to look at that code. You want them to be private. User emails, for example, you want your company's domain to be used, not a Gmail account. Ensuring data is encrypted for Docker registry, GitLab runner AMI has no vulnerabilities. AMIs have vulnerabilities, images have vulnerabilities. Jenkins can be created as an image itself. So you want to ensure that the image that you're using has no new vulnerabilities that are discovered recently. So that's the theme here. So SSO enabled, SSH access to Jenkins agents is disabled. So that's the idea. So security in the pipeline, Michael is going to go into more details on how we have done security in the pipeline, what are the concepts around security scanning, and how do we actually include it in the pipeline, and some ideas around continuous security.
Thank you. So first, we have different type of scanning. First, the static ones. So we look at the source code to make the scans run faster. It's easy to open up some repo and run scans on it. So first, we start from the base layer, the system. So we want to ensure that as we build the containers, the foundations on which we build them are secure. So we want to scan those to make sure that there is no issues there first. And then next is the third-party libraries being pulled by developers to build apps. These days, it's very wasteful if you have to build the whole application from scratch. You want to leverage as many. Is there echo? I don't know where it's coming from. This one is off. I don't know where it's coming from. It's better now? Yeah. Okay, thank you. Finally, your own app layer. Now, after checking that all the libraries that you use are safe, you want to make sure that the code for your own app is secure as well. that it won't fail the top 10 from Europe. And finally, we also put code quality in there because there is a correlation between code quality and code security. Code that has more quality should be easier to maintain, so it should be easier to secure. So we try to improve that side as well to ensure that it's easy long-term to keep that code secure. Finally, the graal of security scanning is the dynamic one. When you look at the application running, looking at the code is one thing, but running the app is this. You have to embed a lot of secrets, and it's only when it's running that it really matters. If your app passes all the static scans but failed the runtime ones, it can still be attacked. But those scans are very tough to put in place because you need your app to be running, which is tough to do as part of CI. It's tough to do as even live because you don't want to hit your prod app too much. So it's one is a tough one to get to. So we try to make all those scannings easier for developers. We write a Jenkins shared library function for them. So this way, it can easily drop it as part of their pipeline and they got OS scanning. Same thing for GitLab CI. They just drop a few lines, they're good to go. Then we have dependencies, then code, and more and more. So as you go, just too much. For a developer creating new apps, if you have to think about all those different tools that you have to integrate in your pipelines, just too much work. Developers are lazy by nature. I'm one, so if I can get away with not doing something, I will. So the way that we found to make this easier is to have one function that does everything. This way they have only one thing to drop in the Jenkins file or their GitLab CI file. It does all the security scanning for them. In the future, we could even think about automatically dropping that code anytime someone creates a new repo. This way, it's much easier for everyone to not deal with all the details of which tool is being used to do what type of scanning, because something new that we see is that we keep changing tools every few years. So something that passes all that scanning at build time is good, but it's not perfect because new CVs are found daily. So if your app passed the build scanning, doesn't mean that once it's running in production, it will still be good. So you want to keep checking your apps even once they are running to make sure that they are not being exposed to new CVs. So we have a weekly process that goes and checks all the containers in prod and gives the list to security of what's new to look at. So having auto scans is nice, but if we don't force people to use them, it's useless. I'm a developer. If you don't force me to use all those static scanning tools, I won't. So for that, we built two tools ourselves, Pipeline Enforcer and Secrets Detector. Pipeline Enforcer just checks that all those scans are part of the pipeline. Process is very simple. Anytime someone pushes code to GitLab, we look at the Jenkins file and the GitLab CI file, checks that those scans are there. If they aren't, we follow a process to let them know that they're not compliant. The code behind it is very simple. We look for strings in files. If you Google how to look for strings in files in Python, it's very similar. We just remove some of the comments. But in the end, it's a really simple type of scans to put in place. So if it fails, you get an email that tells you how to get back to compliance. Because emails are easy to forget, we get a ton of them. We mark the commit as fail in GitLab. This way, if they have the correct merge request settings, they can't even make a merge request. And finally, we put a comment on the commit itself to give them some context as to why the commit was marked as failed. So now that we made sure that the pipelines are safe and secure, we need to look at credentials. As we saw with the Git app, it's very easy for a developer to just embed the credentials as part of the commits because he was testing locally, he was connecting to prod to make sure that the new feature is working with the prod data. Not something they should do, but they still do. So we've built a secrets detector to try to find the secrets in the source code. Again, the process is very simple. Anytime someone makes a commit, we look at the commit content and try to find secrets there. Once we do, we tell the author and the security team of that, so that they can then go through the process of rotating credentials, cleaning up the Git commits, so they have to rewrite the yes. So why did we build our own tool? We took a look at what's in the landscape, and we found that those tools provide value, but they are lacking in some parts. So, for example, the first one is GitLab. They give you a checkbox that's supposed to prevent secrets from getting there. It just looks at file name extensions, so it's not very much. We took a look at a research paper that gave us a lot of the ideas that we put in production for a secrets detector. So I would encourage everyone to take a quick look. It's very easy to read. Lots of insights. But all the rest of the tools, either they work with only the set of regex or based on high entropy strings. Both of those in isolation don't work very well. They give you too many false positives. Once you run them, it finds stuff, but it finds a lot of stuff that you lose time looking into. So our goal was to try to automate a system as much as possible so that we don't have to spend days looking at commits to make sure that they don't contain secrets. So for that, again, it's very simple. We look for regex in a file, but that's not really the real secret. The real secret is that we try to validate when we find secrets, because that's what an attacker would do after running Git for a few minutes. They find some secrets. They're not going to blindly try to attack you with those secrets. They have a limited amount of time that they get to. So first, they want to ensure that the secrets are correct before trying to use them to not waste time. So for each type of secrets that we have as part of finding it, we verify that it's a real secret. So if it's something that looks like a GitHub token, we try to authenticate to GitHub and see if it works. So we have that's our current list of secrets that we find is mainly regex, but we are thinking of embedding more entropy finding in the future to help remove some of the false positive when we are unable to validate that it's a real secret. If we find a DB password, we won't be attacking all our DB servers to try to enter again. So we have to try to find some more ways to reduce the number of false positives, especially when in some cases for a GitHub token, the regex is so generic, it matches a lot of stuff like long Java class names. So we have the system that runs and tells you when it finds a secret, but the issue is that the secrets got in the SCM in the first place. And that's something they want to fix with a pre-commit hook. So we've we've extracted all the logic to run locally. Anytime you try to commit a secret, looks for the content of that commit and goes through the same rules. If it finds something, it blocks the commit. It tells you that it found something so that it makes you think twice about do you really want to commit that secret? It's going to take weeks or months to change that in production. It's going to make you more wary of doing it. And while we are trying to bring it a shift left as much as we can for secret detection, we still need something on the server to make sure that the secrets are not getting there through different ways. Because now that GitLab has like a web IDE, it's easy for people to make changes through the UI and commit them there, and there is no secret detector to catch it. So currently we find the secrets after they are being committed, but we want to remove enough false positives that we can run that same service as a pre-receive hook so that we prevent the commits from being accepted in the CM. That's it. Questions?
Questions, guys? Go ahead.
How has your relationship with your internal auditors been? Have you received feedback from audit?
Some of the work that has been done on this one is coming directly from the auditor. Some of the work they ask for, how is your pipeline doing? Give me a report on, is your pipeline secure? That's the dashboard that we were showing earlier. So that basically covers all of that. So these are the elements that we're checking for, and hence we have these checks that are passed and these checks that are failed. It's a very good report for the auditors. They actually like some of this work. When we've demoed it to them, they're pretty happy with it. We continue to take feedback, and there's a lot of other things that they are doing. Container vulnerability. So Michael talked about production containers, right? Containers that are currently running on production clusters. We continuously scan them, and we figure out that there's some new vulnerabilities that are there for those containers. What is the process then? Because teams will have to be forced to actually fix them, which is out of their release cycle, right? They're forced to actually fix the vulnerabilities just because there's a vulnerability. So there's a dashboard that we've created. There's a process that we put in place. This is all also coming from the audit. As long as there is a high vulnerability, or at least one, or critical, more than 30 days, then it becomes an audit issue. So we're working tightly with the audit team to bring some of this forward. More questions?
How long does it take to recover from something that fails? Like, is your security check in your CI pipeline, and then do they fail like a PR job, and then have to go back and push code again to get the test good?
Yeah. So the concept of smaller code changes, right? So if you make a commit and in your pipeline, if it fails immediately in one of the scanning stages or testing stages, functional testing, for example, you know immediately what commit it is tied to. That's the idea. You're not like bundling a whole bunch of commits in one merge request. Every merge request, every commit for that matter, even in a branch, is getting scanned and your tests are running continuously. Does that make sense?
Like, let's say tests fail and tests take 10 minutes or something like that. How do they recover from a failure? Do they push again, or do they?
They have to push again. So basically that's the idea. So it's small code changes to fix the bugs.
It's also why we try to focus on tools that give us very quick feedback. Because I worked in the past with some security tools that take hours, days to get you results. It's not something that you can easily embed in a CI pipeline. No one will wait that long for those results. So we try to focus on the tools that give us that quick feedback so that we can give that same quick feedback to the developers.
What we don't want is you're deploying a whole bunch of changes to an environment and manual testing happens and a whole bunch of bugs created as a result. And that's a longer feedback loop there. Yes?
It seems that you have employed Git rather than Guardrails. What are your thoughts behind that, and how has it been received by developers?
It's a good question. So what is not shown in there is that the real functions that we use are more extensible. We provide some configuration options to let people that know what they do change the runtime configuration. So it's little less gates, or a gate that you can more easily open if you know how to do it. But it's true that it's our stuff. Finding that line between very hard security and not enough security, and trying to make both sides, app development and security, agree on a common path.
Just to add to that, for every rule that we implement, right, every rule has obviously an exception also. There's valid business reasons for having an exception. So there's a process for all of these where whenever we're checking for a rule, we're also making sure there's an ability for teams to whitelist with a VP approval so they can opt out of some of these checks, as long as there's a valid business reason.
For example, the pre-commit hook won't block you if you say yes. It lets you go through the commit. So we try to take that into account.
Okay. We got a couple more minutes for more questions. This is fun. Go ahead.
How do you bootstrap a new microservice code repo with your, I guess, your pipeline templates with security? I saw the checker, but how do you bootstrap a new code repo?
So currently, it's not something that's really done that much. We have a team that has a bootstrapper, but we come from a more startup world, and when it was still the startup days, we would have something that would automatically drop a Jenkins file into your repo as soon as you create it. So that was one way to try to make sure that as soon as you start a new app, a new pipeline, it's secure by default. It's
We
something
do
that we
have
have to work on.
standard templates in GitLab and Jenkins, which come with a whole bunch of static scanning, dynamic scanning, all built into the pipeline. So as long as the only thing the development team needs to do is to actually populate that template with the code and scripts that they need as a part of that. That's the closest to the bootstrapping we have.
Yeah, making sure that instead of trying to fix what was done, trying to make sure that you start with, from the right foot is the right way of trying to think of this.
Any more questions? Okay, thank you guys.
Thank you.